All right, and welcome back. So today we are going to be continuing our conversation on proportional relationships, aka direct variation. Last time in class, we talked about how to identify proportional relationships on a graph and through a table. We talked about direct variation, which is the fancy name that we use this year for proportional relationships. We talked about how to identify those direct variation examples on a graph and through a table. So today we're going to be extending our knowledge on direct variation and proportional relationships, and we're going to be talking about how to write an equation from a graph and a table that shows direct variation. So we're taking one more step. So here is today's big idea that is on the screen right now. Please copy this down. When a line goes through the origin, like in our last class that we were talking about, the equation for that line is y is equal to mx. And this is not the first time we've seen this. We saw this last class too. When we're talking about direct variation, it has the form y equals mx. And today we're going to be breaking down what this means, what this stands for, and how we're going to be writing equations in y equals mx. So without further ado, let's take some more notes. Let's say we're talking about y is equal to mx. I really want you to write y equals mx really big on your page. Don't be obnoxious though. Take some pride in your work. So we have y is equal to mx. The m stands for our slope. So we've talked a lot about slope, the rise over the run, how much we go up or down compared to how much we go to the right. Our change in y divided by our change in x. We talked about slope for a long time. So now is when we're really going to start to write equations containing slope and its values. When an equation is written in the form y is equal to mx, the coefficient of x describes the rate of change, or again, we call it the slope. Remember, the coefficient is the number attached to a variable. So the coefficient is going to be m here. Coefficient of a term is the number that's getting multiplied by our variable. So the coefficient of x describes the rate of change, or we also call it the slope. We do know this. The graph always will pass through what? It's always going to pass through the origin. Remember, the origin is 0, 0. So I'm going to write that. The origin, again, is 0, 0. A line that has this equation will always pass through the origin. We talked about proportional relationships and direct variation graphs, and they always pass through the origin, 0, 0. Because if we talk about real life examples, let's say we're talking about pizza, right? I'm hungry right now, so I'm going to be talking about food because I'm hungry. Well, I'm Mr. Q, but you know, dad joke. So, cringe. So, if we're talking about pizza, if I buy 0 pizzas, well, I should pay $0, right? I'm not just giving out money for a product that I'm never going to get, right? I don't buy 0 games and get, spend $10. Like that's not the way it works. That's not the way life works, right? So these proportional relationships will always go through 0, 0, as we saw last class. And something is formed. A proportional relationship is formed. Again, we talked about this last class. The proportional relationship between the miles per hour, the pizzas per dollar, right? This proportional relationship is going to be formed. So again, let's go through this. Let's look up top. We have y is equal to mx, where m stands for our slope. When an equation is written in the form y is equal to mx, the coefficient of x describes the rate of change, or we call it the slope. Remember, the coefficient is the number getting multiplied to a variable. So in this case, mx, m is going to be the coefficient. That's going to eventually be a number. The graph will always pass through the origin, 0, 0, and a proportional relationship is going to be formed. So knowing y is equal to mx and m is going to be our slope, what is the slope of each of the following lines? Going to give you a minute to try these out. All right, what is the slope of this first line? Yeah, it's 10. It's 10, the coefficient of our variable. Coefficient is 10. What about in this equation? Y equals negative 120x. Yeah, you guessed it. The slope is going to be negative 120. What about in here? Yeah, our slope is going to be 2 over 3. This fourth equation, y equals 900x. Slope is 900. What about this last equation? Y is equal to negative 11 over 17x. Our slope is going to be equal to negative 11 over 17. Right? It's whatever that number is, that's going to be our slope. So when it comes to dealing with a proportional relationship, we know how to identify proportional relationships on graph. We know how to work with direct variation in graphs. Now we're going to take it one step further. Now we're going to be talking about how to write an equation when it comes to knowing we have a proportional relationship. So let's talk about problem number 3 and graph number 3. Is number 3 a proportional relationship, and how do you know? Well, number 3 is not going to be proportional because it doesn't pass through the origin. It doesn't go through 0, 0. So we know that graph number 3 is not going to be proportional. What about number 4? Is number 4 proportional, and how do we know? Yes, number 4 is proportional. And now we have to come up with the equation. So in order for us to come up with the equation, we have to find the slope. We have to look at this graph and we have to see how much we go up or down compared to how much we go to the right. I'm going to fill you in on a trick. We know they go through 0, 0. So we know this is one of the points that's on the line. It has to be 0, 0. So to find the slope, we go and see where that first intersection is. Right here. It's going to be 4 over 1. And I know that because the y value is 4, my x value is 1. So therefore, the slope is 4 over 1. Slope is equal to 4 over 1, which we know is just equal to 4. Now that we've identified the slope, let's write an equation. Well, we know it's y equals mx, and we know that our slope is 4, so y is equal to 4x. That's it. Our final answer here is y is equal to 4x. That's our answer. We first look to see if it was proportional, and it is. It goes through the origin. We figure out the slope, which is 4 over 1. We went up 4 and right 1. Now you might get tricked up here and say, oh no, we went up 1 and right 1. But the y units go up by 4. So we went up 4 and then right 1. So whatever that first intersection, whatever that coordinate point is, it's going to be the y value over the x value every single time. So that's a little Q-tip for you. When we're dealing with proportional relationships and we're given a graph, if we know it's proportional, we can look for that first coordinate point and the slope will be the y divided by the x. This first coordinate point is 1, 4. So the slope is 4 over 1. Awesome. Awesome. What about a table? What about a table? We need to tell whether or not we have a proportional relationship, and if so, let's write an equation. Well, after you copy down these tables, let's talk about the problems. Number 5, the x values are 3, 6, 9, and 12. My y values are 1, 2, 3, and 4. We have to figure out, is there a way that we can multiply our x values to get to our y values? And this one might kind of stump you up a little bit. If I'm going from 3 to 1, How did I get there? What did I multiply by to get from 3 to 1? I multiplied by 1/3. I technically divided by 3, but we know that division is the inverse of multiplication. So we multiply by 1/3, we take 1/3 of something, or we divide it by 3. Well, let's see if that pattern happens every single time. Let's look at 6 and 2. How does 6 become 2? What number can I multiply 6 by to get to 2? Well, we can multiply by 1/3. Likewise, for 9 over 3, I can multiply by 1/3. And again, 12 to 14 by 1/3. So we went from finding the x and going to the y. Well, we now know our slope. We now know the change in our y over the change in our x. We know this because we identified that multiplying number every single time that x gets multiplied by to give us y. X started as 3 and we multiplied by 1/3, which means that if our slope was 1 over 3, and if it was 1 over 3 times x, 1/3 of 3 gives us 1, which is where we get our y. 1/3 of 6 gives us 2. So we have y is equal to 1 over 3x, because if we take any number that's in this table, it reads us a true statement. We're able to find the number we multiply the x by to give us our y. Again, if we go back to the equation we just wrote, y equals 1/3 x. My x is 3. What is 1/3 of 3? 1. If I have 6, what is 1/3 of 6? 2. What is 1/3 of 9? 3. What is 1/3 of 12? 4. So we were able to find our slope by figuring out the number that we multiply our x by to turn into y. Let's look at number 6. Do we have a proportional relationship? Well, in order for us to do that, we have to find a number that we multiply our x by to get our y. Well, how do we multiply 2 to get 4? Yeah, by 2. Now, in order for this to be proportional, it has to happen every single time. Well, how do we multiply 5 to get 8? Is that by 2? No, it is not. So this is not going to be proportional. If we multiply 8 by 2, do we get 13? No, we should get 16. If we multiply 10 by 2, do we get 23? No, we should get 20 because we know our multiplication facts. And we do not have that constant number that we're multiplying our x by. So number 6 is not proportional. Not proportional. There's no constant factor we multiply x by. In table number 5, in the yellow table to the left, we found that constant factor of 1/3, 1 over 3. So we have y is equal to 1 over 3x. In the red table, number 6, we could not find a constant factor. We found the first one to be 2, and that did not occur every single time. Therefore, the red table is not proportional, but the yellow table is. Awesome. With this in mind, try out these 4 problems. Tell whether x and y are in a proportional relationship, explain your reasoning, and if they are, please be ready to write an equation that represents the relationship. Remember, we're looking for y equals mx. Looking for y is equal to mx if we're able to find a proportional relationship. Try these out and resume when you're ready for the answers. All right, folks, here are the answers. Number 1 is a proportional relationship. We find the slope to be 3 over 1, therefore it's just 3. So we can write it as y equals 3x. The second graph, it is not proportional. It does not go through the origin, so it cannot be a proportional relationship. Number 3, It is not proportional. There is no constant number that we can multiply x by to get y. 4 is proportional. There is a constant number. We multiply our x's by 1/4. 4 times 1/4 is 1. 8 times 1/4 is 2. 12 times 1/4 is 3. 16 times 1/4 is 4. So that's how we get the equation y equals 1/4x, because 1/4 is our slope. It's the number we're multiplying x by every single time. Great job today, folks. Keep up the great work. If you have any questions, please list them below. We are going to be continuing our conversation on writing these equations, and then soon we're going to be going and graphing equations from, or graphing lines from these equations. Right now, we're just talking about how to deduce and write the equations. Soon, we're going to be taking these equations and working backwards to then graph or create a table. But you're doing a great job, folks. I will talk to you soon. Have a great day.